Hello. Welcome to this video. In this one, I will be discussing a one shot on SQL queries. Now, I will just mention some things at the beginning of this video itself. First of all, we will not be covering the fundamentals, as in, this is a revision video totally. So, you will not be taught the concepts from scratch as such, or you won't be spoon fed the concepts. It will just be for the purpose of revision. Also, I will note my time because on this editor I have 30 minutes of limit, right? And we will do this one shot using query wale questions. Okay, and the current set does not have questions on truncate, on creating a table, creating a database, then selecting that database in the workstation. Then there are other things as well related to the alter command. You can alter the properties of a column, properties of a table. You can add new data, you can remove data. These things are not covered here. We will only be dealing with querying and retrieving information. Fine. So before we go for it, I'll mention the schema, which is very important. We just have two schemas here. One is the employee schema, okay, and ENO is the primary key for this table. So we have ENO, we have ename, we have job type, we have manager, we have hire date, we have department number DNO, which is a foreign key, which is referenced from the other table, which is the department table. We have commission. Again, check this one. This is important if the question comes in the exam. Although in the exam, mainly query questions do come in the theory exam. In the practical exam, you have to do everything from scratch. Whenever you are mentioning the decimal data type, this one, the first number mentions the size, as in how many numbers you're going to take or how many digits you're going to take. And the second number denotes the number of decimal places which you will take. And we also have something called salary. And under the department schema, we have field type, we have DNO, we have DName, we have location. Fine? Alright. And there's also a default value, as you can see. While creating a table, you can also mention this thing. Like something, either you write it it is yes null, like it can be null. If you don't mention not null, it means it can be null. Now if the data has not been inserted in a particular row for that attribute, you can assign a default value as well. Here is new Delhi. Fine, that will do. We have 52 questions. We will hop towards our questions and the discussions directly. We will begin with simple questions and go into more complex ones. The first question: display employee name, job, hire date, employee number for each employee with the employee number appearing first. The most simple: select ENO, ename, job type, hire date from the table employee. Also, just to mention one thing, in SQL, the commands are not case sensitive. So instead of writing select, if I also write, say, select, or I write select, it will do. No issues with that. And one thing which works with MySQL, suppose you have created the employee table as employee, but here you type employee in small letters, it will still work. No issues. Fine. So very simple query to begin with, and you get all the data. I'll show the output, but it's not very relevant in this case. The query is which is the most relevant thing. Now, query to display unique jobs from the employee table. Distinct is the keyword. Select distinct job type from the employee table. You get all your answers. Query to display the employee name concatenated by a job separated by a comma. So concat is the aggregate function which has to be used. Concat, you're putting the ename, employee name, you're putting a comma, then you're putting the job. Okay? If you again see, if you remove this space here, then there will be no space between the comma and the job type. So you have to do the formatting yourself. That's how concat works. It gives you full control over how as a string you will display your answer from employee. Again, you will see this for every aggregate function. This is the aggregate function, and this is the output which you are showing. You see this becomes the name of the output column. But if you just rename it, again see, if you write as or as, it's the same thing. If you rename it as name underscore job, then this column name would become name underscore job. Okay. Fourth question, query to display all the data from the employee table. All the data. Separate each column by a comma and name the said column as the output. Okay, it's just an extension of the previous one which I mentioned. Now you could have done select star, but you cannot do it because you have to apply the concat function and you have to format everything together. The output and everything separated by a comma here. Okay. Now query to display the employee. Also, by the way, just saying, instead of using the terminal, use the workbench. Create a script file there and do it that way. I use the terminal only for copy pasting the prompts from my script file to the terminal and taking the screenshot because it just made it more convenient. But other than that, if you have used this, you will know editing and debugging is a difficult job on the terminal. You have to rewrite things again and again if you get it wrong multiple times. Question 5, query to display the employee name and salary of all the employees earning more than 2850. Simple use of the where condition, where where command, sorry, or where clause. Select ename salary from employee where salary is greater than 2850. Simple. And you get an answer like this. Yeah, I am the highest paid employee in this database, alright. Question 6, query to display employee name and department number for the employee number 7900. Clearly they have mentioned. So select ename DNO from employee where ENO equals to 7900. Okay. Question 7, query to display employee name and salary for all employees whose salary is not in the range of 1500 and 2850. Now, this part is the same, of course. Where is also common. What have I written here? Salary not between 1500 and 2850. If you had to write for salary between these, then what would you write? You just remove the not. Salary between this range which has been given. Now, between means it will contain the edge cases, right? So, other than this, how could you write this? You could write this as where salary is greater than or equal to 1500 and salary is less than or equal to 2850. For between, if you have to write not in this range, then you just invert these signs and you are good to go. Okay. Next question again. Yeah, answers have been given. Query to display employee name, job, and hire date of all the employees hired between February 20, 1981 and May 1, 1981. Order the query in ascending order. Quite easy. Select statement is okay. From is okay. Now, where hire date between this and this, the dates. Now, these are not strings, but these are date objects, right? So when you are, although you represent it like strings, you write them between, you know, either single inverted commas or double inverted commas. Both work here. Okay. Suppose you are creating a date. In that case, you have to write it like this, like date, and then you have to mention the format. Format, the default format YYYY MMDD. But other than that, when a date has already been created, a date object, you just use the comparison methods. Now, can we use the other method? can be used like this, like hire date is greater than or equal to this, and hire date is less than or equal to this. Can we write like this? The answer is yes. This also works. Fine. Question number 9. Query to display employee name and department number of all the employees in department 10 and department 30 in the alphabetical order by name. By the way, I missed something in the previous one. Yeah. Order by hire date, ascending. Because you had to do it. Now, if you, although we will have examples like that, if you want to denote it, display it in descending order, you write DSC. If you want to denote it in ascending order, either you don't mention anything because the default order is ascending, or you can also mention ASC if you like that way. Question 9 here. See, select is okay, from is okay, where DNI equals to 10 or DNI equals to 30, order by ename ASC. Fine. And answers have been given here, of course. Answers will always be there. Okay. Now, query to display employee name and salary of employees who earn more than 1500 and are in department 10 or 30. Use parentheses properly, it helps. Okay. Now, why it helps, I'll tell you. So, the where condition here will be DNO. Now, DNO is a collective clause, right? It's a collective clause or condition. Department, either you are in department 10 or in department 30 and salary is greater than 1500. Now you could say, what will happen if I do not put brackets? There will be a problem. What will be the problem? Let me tell you. The thing is, in if you have studied Boolean algebra in computer science, not in physics, okay, if you have studied this in computer science, especially in class 11, if you were from the CISC board, you will know that OR is, now OR is represented as V, and it is also represented as plus, okay, and is represented as ulta V, something like this. It is also represented as dot, and it literally corresponds to the multiplication operation. It literally corresponds to the addition operation. Okay, so for example, if I'm writing a Boolean expression like AB plus C, it means A and B or C. So in our case, if we are to write it like this, what would it be? DNO, again, DNO equals to 10 plus DNO equals to 30 multiplied by salary greater than 1500. The conditions are like this. And the order of precedence as defined by the BODMAS rule do hold here. So if I do not put the bracket, first it will check between these, then it will go for this. So the answer becomes wrong. And that's why we need to put our brackets to get the correct answer. And that's the reason you have to use the brackets here. And you're justifying why we need to put the brackets rather than just stating that you have to do this, otherwise you are going to commit a big sin or something. Answers here. See, I earn. Okay, I'm not there here. Now, query to display name and hire date of every employee who was hired in 1981. Now, here, certain interesting things will come here. Select ename hire date from employee where year of hire date is 1981. Again, it's an object, so you have to mention it between the inverted commas. Double or single, both work as I mentioned. Now, if you want to get the day, what would you do? You would just write day, not this, hire date. You just mention it like this, you'll get it. No issues. If you want to get the month, you'll type month. If you want to get which day of the week it is, what will you type? There's a separate function for that. Day of week. You'll get whether it's Sunday, Monday, Tuesday, whatever that is, depending on the question. or the project application which you're doing. Because, of course, we don't learn it just to give exams, do we? So question 12, query to display name and job of all employees who don't have a current manager. So if you don't have a current manager, your manager will be null. That's the intuition. So where manager is null. That's the point. Do not write manager equals to null. Do not write that. This does not work. Okay? That's because null is not a value that you will compare. It is an entirely different type. So you have to write is null or is not null. Fine? Keep that in mind. See, only the king does not have a manager. Even I have a manager. Query to display the name, salary, and commission for all the employees who earn commission. Sort the data in descending order of salary and commission. Fine. Select e-name, salary, commission from employee where commission is greater than 0. Because if you don't earn a commission, you earn 0 commission. You can also add another condition, by the way, or commi- commission. I think and is better because both will satisfy, right? Both will satisfy. And commission is not null. In this case, both and or will work. So in case in the current design of our database, you put it as null if someone does not earn a commission. There, this will work. At the end of the day, what you write depends on the design of the thing. Order by salary ASC, commission ASC. Now, what's exactly happening here? Also, let me mention this thing. If you write salary, comma, commission ASC, what will happen? Of course, both will be ordered in ascending only, but let's do like this. Suppose you had to represent both in descending order. Now, since you have not mentioned anything, this is separate. This is separate. So this will be done descending in descending order. This will be done in ascending order. Fine. So there you have to mention both. Salary comes first, which means that is the higher priority wala attribute. If there's a tie, then you use this one. And after that, if there's still a tie, then nothing. You just follow the order in which the data was inserted in the database. In that order, the answer will come. Simple. In question 14, query to display name of all the employees where the third letter of the name is A. This is interesting now. So select ename from employee, that's fine. Now, the first thing, while comparing strings, you do not write this. Okay? Although I believe in MySQL it's a single equal to, not a double equal to. So you do not write like this. When you are matching strings, you write like. Okay? Now third letter is A. So what you do in MySQL is you represent characters of a string using underscores. This is one letter, two letters, three letters, four letters, like this. Sorry, I put hyphens. One, two, three, four. Okay? So you want the third letter to be underscore. Sorry, third letter to be A. So put one underscore, two underscore. Exactly in place of the third letter, you put capital A. Then you put percentage. Two underscores in the front means there are exactly two characters before A. And it can take any value. Percentage here means it does not care about how many letters are after A. It could be anything. Okay? So this is more of hard coding the number of letters preceding or succeeding another mentioned character. This one just gives it more freedom. Query to display name of all employees, either like they have two R's or have two A's in their name and are in either department 30 or their manager's employee number is 7788. Now what first, how do you interpret this thing? Either have two R's or have two A's in their name, This is one set, and this is another set. That's interesting, right? So the name condition comes under a single bracket. Either this satisfies or this satisfies, and one of them must satisfy. And this is the second set. Either the department number is 30 or the manager number is, or rather, the employee number of the manager is 7788. Because manager was a foreign key, if you remember the original structure. Fine. Now, one more thing. You see the structure here? Percentage, percentage, percentage. In between them, we have two A's. Now, percentage, as I mentioned, percentage means it does not care how many characters are there. Percentage also means there can be zero characters represented by the percentage, right? So it does not care about anything else, it just needs two capital A's in the whole string. That's why they have written percentage A, percentage A, percentage. If I remove this, it means there must be two A's in the string placed adjacent to each other only. Fine. If I remove this, then one A can be placed anywhere, and the last character should also be A. And this is, you can play around with it like this. Similarly for R, this is simple. Next question, 16. Query to display name, job, salary of all the employees whose job is clerical or analyst, and their salaries are not equal to this, this, and this. They have not mentioned this. You can see the answer already, of course, but I'll just tell you something, and you can use this thing later as well. It's very useful. Okay. अब ये क्या बताऊं, ये तो हर उसमें आता है ना. वेयर जॉब टाइप equals to clerk or job type equals to analyst. How will you know which word to use here? You have to see that from the input data, right? Based on that, you have to check it. And salary not in this. Now, what do we call this? In the language of Python or R, it's called a tuple, right? What is a tuple? Immutable set of items, right? In Java, you won't call it a tuple because it doesn't have, but in Java, arrays are by default immutable, so it pretty much does the same work. Either you can write and start the bracket salary not equal to um, 1,000, then salary not equal to 3,000, salary not equal to, or salary not equal to, sorry, not or, you will write and, right? And salary not equal to 5,000. Or you're gonna like this. So what will it do? It's like a for loop, you can imagine. Salary will be compared against each item in this tuple. If the condition is satisfied, it will do it. Now let me tell you one more thing. In default programming, this is the not equal to operator, right? In MySQL, you can also use this one. This also stands for not equal to. Okay, you can use any one of them. Next question. Query to display the name, salary, commission for all employees where commission amount is greater than their salary increased by 5%. Salary increased by 5% means salary into, or salary plus 5% of salary, or you can say, do it in my way, salary into 105 by 100, or 1.05 into salary. So you are selecting these things where the commission is greater than 1.05 into salary. Okay. Query to display the current date. Simple thing, current date, and it's a function which will give you the current date in date object format. Now, if you are using SQLite 3 in Python, these methods work there, but they also have some other methods. So there you have to check that. MySQL is compatible there, but they also have their own methods for stuff. In 19, query to display employee number, name, salary, and the salary increased by 15%, expressed as an होगा इसमें, absolute whole number. Now, so what will this be? Select ENO name, ये सब ठीक है. Aggregate function round salary into 1.15. Why into 1.15? Increased by 15%. घटाना होगा तो क्या करोगे? 85% of the original. So you'll write 0.85 there. Fine. And when you're writing round this, it will display it. It will round it up to the nearest integer. Okay. If you write 1, it will round it off up to 1 decimal place. If you write it 9, it will round it off up to 9 decimal places. In this way, you can use the round. By the way, what do we call this concept in programming? We call it method overloading or function overloading, right? This is one definition of the function when there's no second argument going in. This is another version of the function, another avatar of the function. Fine. Now query to display name, hire date, salary, review date, which is first Monday after 6 months of employment. This is very, very interesting. This is very, very interesting. So, day of week has come here, by the way. I'll tell you one thing which you just keep in mind that will be helpful for you. In MySQL, the day of the week is denoted by an integer. So the day of week actually returns an integer. Okay. Now, how do the integers go? In MySQL, what is the day of week number for Monday? If you want to know, that answer will be, well, if you guessed it is 1, you are wrong because it starts from Sunday in MySQL. So for Monday, the number is 2. Fine. So what you're doing is, let me just go through the query now. Select ename, hire date, date add. To the hire date, you are adding 6 months. Now interval is a very useful command again. Interval 6 month, which means you are adding 6 months to this date, and you are getting a date. A date is being returned. If you want to add 6 days, you can just write day, not days, day. You want to add 6 years, you can write a year. That will work in this way. So here, this thing returns the date exactly 6 months after the hire date. Plus, you add some more. Interval 8 minus day of the week. Again, date add hire date in interval 6 month. What's exactly happening here? Now, this is something where even I get confused, but we can keep this in mind, and you're gonna hope that this won't come in the theory exam because it's too much for theory, I'll say. So here also what you're getting is, you're getting the 6 month date. Fine. After that, the day exactly, exactly 6 months after that, you are taking the day of the week, which is returning you an integer. Fine. And from this, you are doing mod of 7. I think day won't be there, or it will be there. Whatever, can just try this once and check this. But you do modulus of 7. Why do you do modulus of 7? Because what I mentioned. Also here you're doing 8 minus. We want to find a Monday. I'll have to stop the recording. I'll return because my time limit is up there. I'm returning on the other side. Thank you. Welcome back once again. My time limit was up, but now let's continue. So 8 minus is also something you are doing. Alright. If this date, exactly 6 months after the hire date, is a Monday, the answer you will get is 2. And 2 mod 7 gives you 2. Right? Or did I make a mistake? No, it gets you 2 only. Yes, that's right. And 8 minus 2 gives you 6. And you want to add. Okay, by the way, this day comes from because you want to add these many days, right? Yep. Okay, please bear with me a bit. I won't give you up. This one confuses me a bit. If it was a Monday, you get 2 from here. Then you take the modulus from 7, you get a 2. In fact, I think I'm making a mistake there. Probably I was wrong. I think you need to check it once. Sunday is 7, Monday is 1. Monday is 1. Okay, wait. This is the thing. You get a 1 here. This is a part of the bracket. 8 minus 7 gives you 8 minus 1 gives you 7. 7 mod 7 gives you 0. So you do not add any more days to this. This day itself is the salary review date. If it's a Sunday, 7. 8 minus 7 gives you 1. 1 mod 7 gives you 1. You add 1 day because this day is a Sunday. You add 1 day to the date and that is a salary review date. See, I was giving so much gyan about brackets and all, and I confused it. That's what I was thinking. Also, it might differ from system to system whether Sunday is 1 or Monday is 1. This one works if Sunday is 1. Okay? Sorry, if Monday is 1. Yeah, then it works. Fine. Question 21. Long way to go. Query to display the employees that earn a salary that is higher than the salary of any of the clerks. And any is a keyword, which is a benefit for you. So, this is fine. Where salary is greater than any, a nested query here. Select salary from employee where job type equals to clerk. So, what do you get here? You get a list of tuples, right? You get a list of tuples. But because the tuple has only one, each tuple has only one unit, one item, it is as good as a list of integers only. And the salary of this employee whom you have selected, whose ENO and ename you want to display, if it's his salary is greater than any item inside this list, you just return that. This is the simplest way to understand this thing. Fine. If you want to display the name and calculate the number of months between today and the date each employee was hired, so select ename. Timestamp diff is the function which you want to use, right? There's another way of doing this as well, which I'll tell you, and we have already used that before. If you use timestamp diff, again, what are you doing here? Month, which means you're mentioning you want to find the difference in terms of the number of months, higher date minus the current date. Now, what's the other way of doing it? You'll do the month of current date because current date is greater. In this function, it works in this way only. The earlier date is mentioned first, the later date is mentioned later. So month cur date minus, okay, I made a mistake, sorry. Just a minute. Not like this. You want to get the number of months, you take the cur date and you can subtract. Am I making a mistake here? I think, okay, this won't work. This phone, this is more unsafe. Okay, guys, use this one only, fine. 23. Query to display the following for each employee. E-name earns salary monthly but wants 3x salary. Label column as dream salary. Nothing, a simple use of the concat aggregate function. Concat them. Simple, right? Anything enclosed between quotes is the string item, and these are the variables which I've mentioned here. Simple. 24. Display name and salary for all employees. Format the salary to be 15 characters long, left padded with dollar sign. Now you use L pad for left padding, you use R pad for right padding. This function takes three arguments: the attribute you want to pad, the size of the padding, and what you want to pad to it. Okay. Left pad means answer will be like this. See, there are 15 digits, and for the missing digits on the left, you are padding it with the dollar sign. Okay. Query to display the first letter capitalized and all other lowercase, and length of their name of all the employees whose name starts with J, A, and M. This will be the, okay. So what you want to do here? Select concat upper. Now you write upper for uppercase, lower for lowercase. Upper left ename 1. Now check this. The bracket starts here, the bracket ends here. So this whole thing is inside the concat function. Okay. So to the left ename 1. So you take the first, this is a method of substring, one way of doing the substring. We are taking the leftmost character of ename, converting it into uppercase, concatenating it with the lowercase version of the substring which begins with ename and 2. 2 means the starting element. Okay. If you mention in 9, then what are you doing? You are saying that take the substring from 2 to 1 less than 9. So from position 2 to position 8. If you are mentioning it like this, you are doing it like that. And if you're mentioning left here like that, you do not have to mention the last limit. Okay. But you could also write it like this: substring ename 1 comma 2. It will only have the character at position 1. and and languages like SQL and MATLAB also are, their indices begin from 1 and not from 0 like other programming languages. Keep that in mind. And this part is the length ename as name length from employee, where ename like, as I had mentioned, you do not use equal to for doing with strings. First letter J, rest you don't care. So first letter J or first letter A or first letter M, and you're good to go. See, AJM. Okay. And yeah, see, first letter is this, last letters are like that. Now query to display, although yeah, even by default things were like this only in our particular data set, but it will work. Now query to display name, hire date, and day of the week on which the employee started. Simple. Select the ename, hire date, day name. hire date as day when employee started. Now, if you write day of week, it will return the integer which is equivalent to the day started. If you write day name, you'll get the name as you can see here. Fine. 27. Query to display name and commission amount. If the employee does not earn commission, then use default value no commission. Now keep that in mind. This is very useful actually. Also, there's some other way of using if else, especially in SQLite 3, but case is the most traditional way of doing it. Select ename, then you start a case. When commission is null or commission equal to 0, then no commission is returned. No commission is selected because it's inside the select. Else, cast character as char. Now, do you need to do this? Not really. But there will be cases when you do need to perform explicit typecasting. That's what you are doing here. Okay, here end means the case has ended, and the item selected from this you select it as commission status. And see, so many people don't have any commission. I have the highest commission as well. See, 28. Name, department name, and department number for all the employees. Now, join statement comes here. Okay. Now select ename, dname, but you are using the aliases here. This comes from employee table, these come from the department table. Now you are writing inner join department D. If you just write join, even that stands for inner join itself, so it will work anyway, right? Instead of this, if you write department D, just using comma, what are you doing? You are doing the full outer join? No, you are doing cross join, or what we call the cross product in set theory. And after doing the cross product, you are applying this condition. Then you are extracting the values. Does it make a difference? Not in terms of the results, but it does add more overhead. So if you're working with a very heavy data set, it will cause more time wastage, and more it will take more processing power and time. So the best way is, while selecting the items itself, you check the condition, then only you select inner join. Better option. Query to display unique listing of all the jobs that are in department 30. So select distinct job type from employee where DNO is 30. If you remember, DNO was also a foreign key in the employee table, so this will work. Here you have it. Query to display name, department name, and location for all the employees earning a commission. So select e.ename, d.dname, d.location. From employee E, inner join department D. Now you write inner join or only join, it's the same thing. On e.dno equals to d.dno. You're pairing it up such that your table is synced with the same department. Okay, and let me just check this. Did we make a mistake here? See, this part is correct, where commission is not null and commission is greater than 0. Greater than 0 not equal to 0 will make sense. Uh, these are the things you want to display. Fine. But why are we doing this? That's interesting. It's quite interesting. Did we close the document? Let me check once. Department has dname, dno, dname. This has dno. So dno is actually the only foreign key which it has. So there's no other option. No, manager is a foreign key, but to itself. It is a self loop. to the employee number itself. But here, let me just check. What was the question? For all the employees earning a commission. Yeah, this will work. Now, why will it work? You are basically, we need to think about this. I have this intuition that this whole data set might be insufficient to solve this particular question. If you have an answer to this, you can write it down in the comment section below. So I'll leave this question and I'll move on to the next question. Okay. And I think, yeah, there will be more. There will be nested things as well, stuff like that. Yep, there will be more to this. It's not that simple. There will be nests here. Query to display name, department name of all employees who have A in their name. So employee, inner join department D, condition where departments are matching. Now what you have to display? Name means the employee name and department name of all the employees who have A in their name. So where E name like this. Wait, why have I done this? Let me take a break. I'm coming back soon. Alright, guys, I just needed a sip of water. It's correct, it's not wrong. Why will it be wrong? See, what does the department table in have? It just has these things, right? Department number, department name, location. Yeah, exactly. So you're just attaching that to the employee, depending on which department the employee is working for, right? So employee, again, see, we have the table of employees. Along with each employee tuple or row or entry, we are attaching the details of his specific department. That's all. But we are still picking up from tuples containing unique employee data. So this will work. Simple. Sorry for the abstraction. So yeah, simple way of joining employees with their departments, and this is our condition. Again, if I just show you the question, see, technically we just have to check on the employee. We are attaching or joining the department table just because we have to also display the department name, not the number. As simple as that. Next question. A query to display name, job, department number, and department name for all the employees working at the Dallas location. So what will you do here? You'll join the employee table and the department table based on the department number condition, and d dot location should be equal to Dallas. Simple. 33. Now we have some special things coming up. Query to display name and employee number along with manager's name and manager's employee number. Okay. Now I'll just say one thing, that manager's employee number is the candidate's or the employee's manager number. Anyway, so select e dot e name as employee name, e dot eno as employee number, f dot e name as manager name, f dot eno, comma na as manager eno. Okay. From employee join, self join, as we mentioned, self loop employee f. Now e dot manager should be f dot eno. Why? Because the manager number of the original employee is the employee number of the manager, and in this way you just display everyone along with the manager's name and manager's number. I think I missed something here. right? You have to use this. That is Col SC. I don't know how to pronounce it. And I believe this is the correct one. When you type this, if this exists, I made a mistake actually. No, it won't be here. But let me just tell you the concept. What this will do is, if this is present here, if this is not null, it will take this and put it here. If it's null, it will take this and put it here. But here we don't need it. This will work. Okay. And this is our answer. Also, let me just. I'm thinking, why have I put this? Ah, I forgot. Sorry. And if you do not put this, it will work. And I'm not on the workbench that I'll experiment. Sorry for that. Moving on. Query to display name and employee number along with the manager's name and manager's employee number along with the employee's name who don't have a manager. Okay, here you see. Cool. This one comes in. Okay, to handle the null values. Okay, just a minute. This question did not actually remove this. Fine, remove this here. So, okay, let's try to visualize. What are we doing? We have the list of employees. On the employees, we are performing not a normal join but a left join, such that if something on the right side does not match or the condition does not match, on the right side we keep it as null. Okay, basically for the king in our database, basically, or for anyone for whom it could have applied, e dot manager, which gives the employee number of the manager, would be null if there is no manager. So null equals to e f dot eno. This won't work, right? So left join will retain the tuple of that employee as well, and in place of f dot ename and f dot eno, it will put the string na. Okay, I mentioned this function. It handles null values. If this is not null, it will put this here. If this is null, it will put this handled value here. Fine. Next, 35, query to display the employee number, name, and salary for all employees who earn more than the average salary of whom of all the employees, and who work in a department with any employee with a T in his or her name. Now this is interesting. A lot of nests coming in. Select e.eno, e.ename, e.salary. Fine. From employee E, fine. Where the salary of this employee is greater than, select average salary from employee. And I'm telling this part, but before that, what I have mentioned, select actually returns your answers as a tuple. But if the tuple has only one item, then it's very well a primitive data type itself, like int or string. Average salary returns only one integer, not integer but a floating point value, only one. So you can compare this with the answer of this, and that's the logic. You calculate separately the average salary from the employee table, compare it with this. This salary should be greater than the average salary of all the employees in the employee table. Now the second condition, e.dno in select d.dno from employee D where D name like this. Now with a T in his or her name they have mentioned, so there will be one more, this one here. Okay. Now what's happening here? This will return all the department numbers where there's an employee with this. Okay, all the department numbers. Whether will there be repeats? Yes, there will be repetitions as well. And this will give us a tuple of, this whole thing will give us a tuple of department numbers. Out of them, if any one matches with this, because they have mentioned any employee with D in his or her name, this condition is satisfied and we get our desired answer. This thing is there. Now, query to display name, department number, and salary of any employee whose department number and salary matches with, again, whose department number, salary of any employee whose department number and salary matches with both the department number and the salary of any employee who earns a commission. So, what's the thought process? You get a tuple of all, again, tuple as in tuple containing the department number and salary of all the employees who earn a commission, and compare it with our original list, which is this condition. You display the name, department number, salary of any employee, means जितने भी लोग हो सबके करने हैं. If this employee's department number, salary matches both the department number and salary of any employee who earns a commission, irrespective of whether this employee earns a commission or not, you display that. So what will you do? Select and from is okay, but where you create a tuple, because you have two values, and here you see select f dno f dot dno f dot salary. So this will return a list of tuples. Condition is the same for the commission. You compare this tuple with each tuple in the returned list, and whenever there's a match, you display these. Okay, that's our answer. Query to display name. Okay, what's happening? It's fine, right? Yeah. Query to display name, hire date of any employee hired after the employee Blake was hired by the company. So it's easy. Select ename hire date from employee find, where hire date of this employee whom we want to select is greater than, again, select the hire date for the employee named Blake. Quite simple, easy. 38. Query to display name and hire dates of all employees along with their manager's name and hire date for all employees who were hired before the managers. Now, one condition will be similar on how you want to join the managers. So you selected the employee name, selected the hire date of the employee, selected the manager data, you joined them together such that condition is what? Manager number of the current employee equals to the employee number of the employee of the table which we're considering for the managers, and just that, put the condition e dot hire date is less than f dot hire date. Now if someone is hired earlier, that's before, less than, that's not greater than. Okay, we make silly mistakes, that's why I'm clarifying. And this is a beautiful table. You get this. Now, query to display name and salaries represented by asterisks, each asterisk signifying $100, which means number of asterisks equals to 100 into that amount of money. For this, we again use an inbuilt function. Repeat. What do you want to repeat? And how many times do you want to repeat? Okay, salary by 100 because each star is worth $100. And this. There was another condition to actually put an upper bound to the number of stars which we are representing. I'm not discussing it now because I don't want to pause the video again and I have forgotten how to do it. Sorry for that once again. Query to display the highest, lowest sum and average salaries of all the employees. Now it is a simple thing, just using aggregate functions, right? Max salary, min salary, sum of the salaries, average salary. But is there a problem? No, not really, because all of them will return only one value each. So everything wraps up in just one tuple. 41. Highest, lowest sum and average salary for each unique job type. Good question. Easy question. You have to select the distinct job type along with these data and group by the job type. And this is how it will look. Beautiful. 42. Query to display the number of employees performing the same job type functions. So again, select distinct job type, count the number of employees as number of employees from employee group by job type. Okay, and you get your answer. Again, so distinct job type, count e-name. If this thing was not there, it would give us the total number of employees in the whole table. You mentioned this and you group by this job type, so you get a beautiful presentation like this here. 43. Select display the number of managers without listing their names. So again, select count because the number of managers, distinct manager, you, you want to get the unique number of managers from employee. It was easy as well. See, just one cell for the answer. Query to display the difference between the highest and lowest salaries. Display the difference between, how will you do it? Max salary minus mean salary. Min, not mean. They are different. And you get it. Query to display the manager's number and the salary of the lowest paid employee for that respective manager. Exclude anyone where the manager ID is not known. Exclude any groups where the minimum salary is less than 1000. Fine, let's address this. First thing, display the manager's number and the salary of the lowest paid employee for that respective manager. Now, select manager min salary as min salary from employee where manager is not null, group by manager. So you get the minimum salary for each manager only in cases where there is a manager. And as they mentioned, exclude anyone where manager ID is not known. And also group by manager having minimum salary greater than 1000. Okay. Now, when you are mentioning a condition along with the group by clause, if you want to write where, it does not work. This does not work. You have to write having. But in my experience, like here again, having won't work, most probably. But suppose in some normal case, suppose you're just writing where salary equals to, we just write some other way. So like you select something, okay, I'll just tell it. You select ename from employee where salary is greater than 2000. There if you write having, it does yield the result. It's not that it won't work in that case. But it's still important for you to know the difference between where and having and when to use what. 46, I'll quickly check the duration, which is 18 minutes, fine. Query to display the department name, location name, number of employees, average salary for all the employees in the department. Now, let's do it, okay? You have to join the tables once again. Department name, department location, count the number of employees, and average salary from this department. Join the employee table with it. Put the condition of the department numbers. You have to group by D name and D location. Now, what they have mentioned in the question, they have not mentioned anything, but I got this while doing it actually. In MySQL, it is going to give you the result if you group by both the D name and the D location actually. And this is also relevant because each location only contains one D name for our data set. If you remove one of them, it actually gives you an error. That's what I had seen, if I remember things correctly. So when you get such a case, you can understand from my voice that I'm getting confused a bit once again. But yeah, fine. If you want to group by basically the tuple of the department table, because each tuple denotes each department and you want to group it by the department, you do it using both dname and dlocation. 47, query to display the name and hire date for all employees in the same department as Blake. So the where condition will be department number, which is a part of employee table itself. You select the DNA from employee where the ename is Blake. So just retrieve Blake's department number, compare it. If it matches, you display all the names and hire dates. My voice is getting hoarse. So it might be a right decision to not become a full-time teacher or lecturer with this weak voice. Whatever. Query to display the employee number and name for all employees who earn more than the average salary. Now we have some easier prompts towards the end, right? Select ename, eno खाओ, acidity को दूर भगाओ from employee where salary is greater than. Now you have to select the average salary, basically calculate the average salary. And by the way, if you try to write like this, if you try to write like this, salary is greater than average salary, it does not work, okay? Inside a where clause, without a select clause, aggregate functions cannot perform calculations. That's why you need this, okay? Now 49, query to display employee number and name for all employees who work in a department with any employee whose name contains T. We have done this actually. Select the employee number, employee name. DNO is again select distinct DNO. Even if you don't write distinct, it will work, but it might increase the overhead. That's all. Select distinct DNO from employee where ename like this. Now contains bola hai to you just make it this. Okay, you get all the department numbers where some employee has T in capital T in the name, and compare the department number here, list comparison, tuple comparison, and you display them. If you just wanted to visualize what's exactly happening here, so distinct is actually applied later, you know, because SQL will read clearly that you only want this and nothing else. It will find the list containing all the things, all the department numbers, then it will merge the common ones and make a shortened list, and then you can use that for your comparison. My roommate is unable to sleep, and I am teaching you here approximately 28 hours until my DBMS exam. Fine. I bless him with sleep. Question 50. I'll check the time once again. Okay, 6 minutes. We have query to display the employee name and salary of all employees who report to the king. I report to the king. You'll see that in, oh, it's visible already. See? Select e-name salary from employee where manager equals to what? You have to select the employee number of the king. Compare it with the employee's manager number. By now you have understood how the tables work for our database. And that's all. Question 51. Query to display the department number, name, and job for all employees in the sales department. Do you have to join? Of course you have to. Select e.dno, e.ename, e.job type from employee join, or the same condition as always, where department name is sales. That's right, actually. That's how the department was. Yeah. Yeah, that's how it's named. Finally, select manager name getting salary greater than the average salary of the employees in his department. So again, select m.ename from employee M. M I've written because we are dealing with the manager now, where the employee number of the manager is in this thing. See, select distinct manager from employee, where manager is not null. So we are considering those employees where manager exists, and the salary of our manager is greater than the average salary, such that we are considering only those employees who work in the same department as our current manager. That was the question. If you see, manager getting salary greater than the average salary of employees in his department. And that's it. We still have some minutes and end it with the story time, the story of our DBMS Viva. So we went in with a group, and Shobha Rai ma'am was taking the Viva this time as well. She did. She has taken a lot of my Vivas actually. There was one student in our group. Ma'am asked him, "What's the meaning of the division operator?" He could not answer. She asked me, I said it correctly. Then she asked him, "What is left outer join?" He tried to explain it, but it was very bad and it was not proper. She told me to answer the thing, and I answered it. After this, she asked him, "Okay, left ka answer sun liya. Now tell me what is the right outer join." He could not answer that as well. And then, as he was thinking about the thing, ma'am looked at me. She was laughing. I was also laughing, and it was a funny incident. Whatever. Thanks for watching. Hope it helps. and write down anything in the comment section which you would like to know, or if you need anything. Thank you.